Thank you, Jess. All right, can you hear me well? Everyone hears me. Okay, so as I was introduced, I'm Anna Migas, and the title of my talk is Fast but Not Furious: Debugging User Interaction Performance Issues. During past few years, I've had a chance to develop and maintain free open source libraries all about animations. And during that time, I was really focusing on performance and making the best out of this library so that they would be really best performing experience for our users. And during that time, I read a ton of articles on performance, and I saw one term really emerging in performance world, and it was perceived performance. And while it is hard to find one definition of perceived performance, it usually boils down to two things when it comes to web development. It's about first meaningful paint and time to interactive, where first meaningful paint means how fast the first meaningful content is viewed by the user, and time to interactive is how long it takes for the user to start interacting with the contents of the page that are loaded. And if you searched even further for articles on perceived performance, you would find things like how to optimize critical rendering path, which means how to extract the part of the code from the website that is above default and serve it first. How to use progress bars instead of spinners because they will give user the illusion that something is loading faster. Or how to have a placeholder content, so this gray areas that mark places where the content is going to be loaded in a minute. Like Facebook does, for example, or even how some pages start uploading the media before even the user knows they want to upload the media. They only have chosen the media on their device's media library. So I don't really agree with calling all of this perceived performance, because I believe that this is more about faking how things load, if they load fast. So I would call it actually perceived load performance. And this is more about caring if the road to seeing the website is fine for the user, but then just leaving them to themselves when the content is actually loaded. And I believe that we should really strive for real perceived performance when not only the road to delivering the website is fine, but also the experience on the page. So I believe that perceived performance is not only first meaningful paint and time to interactive. I believe it's about the page being smooth at all times. So we're going to talk about it today. We'll start with why sometimes interactions feel slow. Then we'll go to browser rendering and frames and types of triggered changes in the UI. Then I'll tell you briefly how to test for the performance issues in the interactions, and then about some potentially dangerous interface patterns that you might be using. So why sometimes interactions feel slow? The reason here is junk. Junk can be generally described as lack of smoothness, as a bit of stuttering, as of things that just don't feel really smooth and nice, and it usually can be seen in animations. So junk happens when the browser refresh rate doesn't hit the refresh rate of our device. This means that most of our consumer market devices are 60 frames per second. They have 60 frames per second refresh rate. This means that if we divide 1 second, which is 1000 milliseconds, by 60, we get 60 milliseconds for each frame. This is how fast the browser needs to create one frame. But actually, there are some devices rolling out to the market that have a higher refresh rate of 120 frames per second. These are namely the new iPads Pro and Razer gaming smartphones. This means that we have half the time we used to have before. And to be honest, we already were struggling to hit the 60 milliseconds time with our animations, for example. So what we can do to support this, what can we do to avoid junk, to have our performance better? We should try to start working in between frames to to offload some work from the browser. So the bottom line is that if we interact with the page, the browser needs to start serving frames, be it 60 or 2000 frames per second. But what actually a frame consists of? Frame has a sequence of steps that they don't happen at the same time. You can't have, for example, paint before the JavaScript or layout after compositing layers. They all have to happen in the sequence. But what all the steps do? Like what happens in each of the steps? Because this is something that we can actually leverage for making our performance better. Let's go through it quickly. So first the change happens and an event is fired. It doesn't necessarily have to be JavaScript. It can be hovering, scrolling, clicking a button that shows something to the user. After that, we need to recalculate the styles accordingly to the change that just happened. After that, the browser is calculating the layout. So at this point, the browser will try to figure out how much space each element is going to take, where it's going to be positioned, and it's going to present this as a collection of vector boxes. After we know where elements are positioned, everything is getting rasterized and painted to the layers. We already have pixels at this point, so we take these vector boxes and then we turn them into pixels. So you can think of layers as of layers in Photoshop. If you have two things on different layers, you can move them around nicely and they will not affect each other. But if you have two things on the same layer, they're just glued together and there's not much you can do. So this is something that you can actually leverage during animating things. So by default, the browser has everything on one layer, but there are some things that actually create more layers. There are namely 3D or perspective transforms. If we use animated 2D transforms and opacity, if we have element that is on top or a child of already existing layer, if we use accelerated CSS filters, in some special cases video, canvas, plugins like Silverlight or Flash, and there's one thing that lets us explicitly tell the browser that this area is going to be changing a lot, like I want to put this on another layer, and this is namely will change CSS property. Using will change shouldn't be much of a problem. We just need to tell the browser which property is going to change up front. So here, if we wanted to have hover action, we just say will change transform, and the browser will know that this part of the page needs to be on another layer up front. There is one thing though. Each layer consumes memory, so you should use them wisely. If you have too many layers at once, some less powerful devices can actually crash the browser, and this is not the experience we want for our users. So just be careful with the layers. Then the last step is compositing. Compositing is just taking all the layers that we've had and just putting them into one frame, just putting them into one image. Compositing happens on the GPU, not the CPU, so it's a bit of loading of the work from the processor. And it also happens always if we have more than one layer. But I said that these are some steps in the sequence in our frame. They don't necessarily need to happen all. There are like better and worse types of trigger changes. And this is something we can also leverage during, for example, animations or hover effects or something like that. So there's the first type of change is layout change, also called a reflow. It happens when we change properties like width, height, display, or margins. And unfortunately, this is a very heavy type of change because we change the whole geometry of the page and then we need to go through the paint and through compositing. So it's like we should actually avoid this type of change. It's really heavy. Then we have the paint change. At this point, the browser knows exactly how much space each element is going to take, where it's going to be positioned, so there is no problem with layout. We can skip this step. This happens when we change properties like background color, box shadow, color, background image, and such. This is a bit less terrible type of change, but we still should avoid it because sometimes it can be actually the most heavy part of the rendering steps. And then there is a compositing change. It happens when we change properties such as transform and opacity. And this is the most optimal change because compositing is going to happen anyway if we have more than one layer and it's happening on the GPU. So this is optimal change. This means that we should use transform and opacity for animations and hover effects. So we know about these trigger changes, but how we can actually test if we have a problem? What are the best tools to do it? With reflows, it can be quite obvious. If you have element that is pushing other elements around or element that is changing its size, it basically means that probably you're experiencing a reflow. Unfortunately, with Repaint, it's not that obvious. In this example, the Repaint happens if we trigger the last star on the right, because it doesn't. The Repaint wouldn't happen then because we don't overlap the text. The Repaints happen when we overlap the text, for example. So this is something that you're not going to see with your bare eye. You need better tools for that. And it happens that developer tools in our browser are just perfect for testing all of that. Both Chrome and Firefox have great tools for that. The first one is the performance tab. If you enter the tab, it will show you how long the frames are taking. This is the green bar at the top. And if you click on any of the frames, see like longish frame, it will tell you which part of the rendering process took how much time, and you will know what you can actually start optimizing. To use it, you need to hit this dot, then start interacting with the page. And after that, just finish recording the video. The shorter the video, the better, because it's easier to spot some long frames. Then we have the Layers tab, also in Chrome. You can enable it by going to this three-dot menu on the top right, then going to More Tools, and you have there then a lot more tools than you'd expect. Layers tab shows us the stacking context of the page, so we can see all the layers that are created. It also tells us why each layer was created, so if you can see if you have any excess layers that shouldn't be there, and you can debug that. Unfortunately, Layers tab is sometimes quite heavy. Sometimes it will crash my browser. Thankfully, we have also Rendering tab. It also shows us the flash painting. Also, it will show us the layer borders, some FPS meter, and if we have scrolling performance issues. It's enabled the same way as the Layers tab. And it's a great tool. This is how it looks in use. The green areas are what gets repainted every time you start scrolling Facebook. So you can see how much overload it gives us there, because we have so many elements. You might also want to enable paint flashing in Firefox. There is a toggle in the settings tab, because sometimes different things would trigger Repaint in Chrome and in Firefox. So you need to test both, and also other browsers. And last but not least, there is a Performance Monitor tab in Chrome. So you just enter that and you start interacting with the page. It will show you like CPU usage, reflows, and repaints. To give you an example, when I was interacting with the page that was optimized, there was like around 3 to 8% of CPU usage, no reflows at all, hardly any repaints. With the page that was not optimized, I would get around 70 to 80% of CPU usage, a lot of reflows, a lot of repaints. If you see something like that with your page, you know you need to start optimizing. But these were the tools, but sometimes you don't really, like your page might be big, you might not know what to start with, what to start optimizing. But there are some potentially dangerous UI patterns that are bound to cause problems if you don't optimize them up front. So let's go through them quickly. First of all, we have animations. If the animation is not optimized, you can be sure that some users will experience junk. What can we do about that? First, don't overuse animations. If you have animations that don't guide the user to the app, that don't help with understanding what is happening on the screen, you probably can get rid of the animation. Also, you should only animate transforms and opacity if it's possible, because of the compositing and the GPU usage. If you want to now support this 120 frames per second devices with animations, you should rather avoid using request animation frame. This is because some of the browsers have a cap of 60 frames per second. It will never go to 120 frames per second with request animation frame. It's an implementation feature there. But you are good to go with CSS animations or using Web Animation API with a polyfill. Also, you shouldn't animate elements that are below other elements because of the layer creation. And even if your animations are like super optimized, if you're trying to animate like 100 elements, it's not going to be performing well. So you should rather avoid that. Then there's my favorite parallax effect. I actually tried to, oh, it's not what it looks like on my screen. All right. I actually tried to find like well-performing parallax effect, and this was what I found. And what you see here, like these green areas, it repaints like the whole browser window with every frame. This means that we are experiencing a paint storm. And this is not good for performance, as you can probably guess. It's always bad to use parallax effect. You shouldn't use scroll events. You shouldn't use background position for that. If you really need parallax effect, use 3D transforms and perspective to achieve this effect. And here you have a link with how to do that. Then there are fixed elements. They're pretty popular recently, like using fixed headers, fixed whatever. And what happens then, this fixed element would get repainted with every frame because, well, the browser needs to create this image with this fixed element on each frame. But fortunately, there is quite easy fix. You can use will change for this element, or you can use transform translate 3D. It also creates layers, as I said. 3D transforms promote elements to another layer, and it should fix the problem. Of course, if you have too many fixed elements, you should rather try to remove some fixedness of them and not have too many layers. Scrolling events, they can really cause some bad performance for us. You shouldn't attach will or attach listeners to the whole browser window because it's really not a good idea in general. If you need to attach some scroll events, you should rather try some smaller area that is separated, and you can take advantage of passive event listeners. So if you attach scroll events to the page, the browser is anticipating that this function might at some point call prevent default. That can cause some stuttering, some junk. So if you use passive true flag, of course use it with polyfill, it basically says to the browser, like, I'm never going to use prevent default in this function. You can be safe. You can just nicely make use of the scroll events. Then we have hover effects. Usually they're not a problem unless you have too many of them, and if the areas that you can hover and trigger them are very big and you can hit them easily when you're, for example, scrolling, because on Firefox, unfortunately, sometimes you can hit such areas while scrolling. In Chrome, it doesn't really happen. That's why you should test all the browsers. So if you know that you're going to have, if you know that your user is bound to start interacting with this element and hovering over it, you might consider adding will change property. Yeah, they can be deadly if there are too many of them. And again, avoid all the interactions that can trigger layout or paint. Here's a link to CSS triggers, which tells you exactly like which properties are going to be triggered, which properties will trigger layout or paint. And last but not least, appending elements. This can be like the most deadly because it can cause reflows. What you can see here is like we're appending an element and the rest of the page needs to get repainted. This is because there is no context, like no another container for this part. So like the whole page to the down needs to get repainted. This can be avoided if we actually make sure that not many elements are going to be affected, and if we try to separate the area again using, for example, layer or contain layout, which unfortunately only is supported in Chrome for now. But it's going to be great if it gets more support, because it means like we take element and we say like nothing from inside this element should affect the rest of the page, and the rest of the page shouldn't affect the insides of this element. Also, you can actually try to not change the size of the area, have a fixed height overflow property, and just have will change to put it on another layer. This can be also a great solution. So these were all the tips that I had regarding the interaction performance, and let's see what the takeaways are. So junk happens when the browser doesn't finish rendering a frame on time. Then we have the stuttering. We should try to offload the main thread and optimize it, so use all the optimizations possible. But we also shouldn't overuse the layers and avoid content repaints and reflows. Unfortunately, we always need to test for everything before we start doing any optimizations, because sometimes it can be too much, and be responsible of using dangerous UI patterns. And please, if you can, spare your users parallax effect. So here's the list of resources. I'll post the slides later, and thank you.